Our experiment is Micromeretics, which is the science and technology of fine powder. Our aims today is to measure the densities of powder. Looking at this picture, we have powder. We have three volumes. Bulk volume, which is the volume of the powder, true volume of the powder, plus the volume of cracks or fissure inside, which is intravoids, volume of intravoids, and the volume of intervoids between the particles. So bulk volume is the largest volume. If we want to exclude the volume of intervoids, we will get the volume of a true powder plus intravoidage, that is a granular volume, and the stable and constant volume, which is the volume of the powder itself, true volume of the powder. If we really want to rank the volume, the bulk volume will be the largest, then the granular volume, and the smallest and constant volume is the true volume. As we know, we can measure or calculate the density of a powder using that equation by dividing the mass by the required volume. So according to the volume measured, we can get three densities. As you know, we can really rank the densities as such because the true volume is the smallest volume that enables us to get the largest density compared to the smallest density, which is the bulk density. So we starting with measuring the bulk density of zinc oxide using 10 grams zinc oxide added just to the cylinder and read the volume. It may be get slanted volume, and we get the average of high and low values. Then the next step is to take the same cylinder and tap it for 2 minutes by making one tap on the bench from 1 inch height every 2 seconds. Then measure the volume. It will make rearrangement. Nothing will disappear, just the intervoids will be reduced. Then we will take the volume and measure the tap density. So starting with measuring tap density and bulk density, we need 10 grams of zinc oxide and cylinder, 10 ml, 25 ml cylinder. So I need a watch. Just roughly adding the powder to the cylinder and just read the volume. I have the upper values is 20 ml and the lower value, which is around 16 ml. So by taking 20 plus 16 divided by 2, I can get the bulk volume. Then the next step, using the same cylinder, I need to use a watch to adjust the tapping procedure. From 1 inch height, I will make a tap every 2 seconds for 2 minutes. After 2 minutes, we get the volume of which will be around 14 ml. The second part we will measure granular density of zinc oxide using 2 grams, just 2 grams and 50 ml volumetric cylinder. We will use a dry empty cylinder just by weighing technique. The technique is called liquid replacement, starting 4 steps from step 1, just weighing the empty cylinder, dry cylinder, and get the weight. Then the 2 grams of zinc oxide is added to the same cylinder and reweight as W2. Then we will add water to the zinc oxide for 2 reasons, because it not dissolve zinc oxide and zinc oxide is weighted by water. So adding just water QS2 20 ml and using a glass rod just enable water to enter inside the intervoids. Water cannot get inside intervoids because of the surface tension. So the volume measured is the granular volume, which is the volume of the true volume of the solid plus the intra-volume. So we will add, as we said, water QS2 20 ml using the glass rod, enabling the water to enter inside intervoidage. Because the glass rod will retain some of the zinc oxide powder, we have to rinse it and wash it above the cylinder, and all the powder must remain or re-enter to the cylinder. Then the cylinder completed to 50 ml as maximum. This step is followed by reweighting W3 of the same cylinder containing 2 grams of zinc oxide and water QS to 50 ml. The water weight is the water in the intervoidage and the volume complete to 50 ml. Using the same cylinder, we have to discard the content of that cylinder in the sink and clean it and dry it, and add just water for 50 ml and weight it again. The W4 is the water weight plus the weight of that cylinder. We can really use this equation to calculate the granular volume by subtracting W4 from W1. Will get the volume or the weight of the water minus W3 minus W2. We will get the volume of the water where the powder is in. So because really the density of water is almost 1 gram per ml, so the weight is the same. VG is equal to WG is equal to VG. Okay, so نروح هنا granular volume, granular density. We use a dry 50 ml volumetric cylinder. We get W1, which the weight of empty cylinder. Then we add 2 grams of zinc oxide inside, and W2 will be the weight of the same cylinder plus the weight of 2 grams zinc oxide. Then the next step is adding the replacement liquid, which is water. As we said, we will add water up to 20 ml because zinc oxide does not dissolve in water and it is just weighted by water, and we have to enhance water entering between the particles and intervoids. We have to stir it because really we have very fine zinc oxide. To get accurate result, I have to rinse the cylinder, but be careful not to exceed the volume of 50 ml. The third step is weighing the suspension containing 2 grams zinc oxide and water in the same cylinder. This is W3. The fourth step, we have to discard the powder. I need the drying tissue, please. Cleaning the same cylinder from the content of zinc oxide and water. Dry it from the outside to get accurate results, and dry the basement, just adding water, 50 ml of water. And re-weight it as W4. By using the previous equation, we can subtract W4 from W1, then subtract W3 from W2 to get directly Vg. Then we can divide 2 grams by this volume to get the granular density. The second step in Micromeretics lab is to measure the particle size distribution of our sample. We have a nest of sieves arranged from the coarse to the fine and ended by a tray. We really have 5 sieves, as we said, 2000 micrometer aperture, then followed by 1000 micrometer, then followed by 500 micrometer, followed by 180 micrometer, and finally by 63 micrometer. And to collect the powders less than 63 micrometer, we put a tray at the bottom of that nest. To see that sieves, we have standardized sieve with certain aperture. If really put a powder inside and make vibration for standardized time and speed, the powder will be distributed according to the surface area. The powder which exhibit the same aperture size and above will remain in the sieves, while the powder which has less surface area will be at the next sieve. So the powder will be distributed according to the surface area. After making the sieving time, we take each sieve and weight the powder inside, and we make a draw to make a distribution of that sample to see what is the mean, what is the mode, what is the average size or surface area of our particles. Okay, we add really 2,000 grams of our sample to this sieving nest, and we will start working that sieve for shaking vibration for 5 minutes as standardized sieve, not more, not less, to get accurate results.